Yeah, so sorry about the last one. I know you had to go because a tree fell on you, but the also I ran out of storage partway through. I have a backup recording, um, but unfortunately, um, it requires some trimming because I left it on and then went to the toilet. So I need to cut that out before I send it over or post it up.
Okay, so you need some editing for privacy.
A little bit of editing, yeah.
It was a really good conversation, so hopefully we've captured it all.
Yeah, we only missed the last we missed the last 40 minutes, but we caught the gist of it all. Um,
Yeah, good. I think the last 40 minutes probably, as is our want, we're just re-chewing over what we were saying in the first hour. It seems to be
that
a bit
was where
more
we
like
were.
that.
I was trying to move through the different services like email,
Oh,
and
that's right.
so
That's right. We
yeah,
moved on the
and then we
topic.
were
Yeah.
recognizing that actually making a dark edge app platform for Africa, where there's like one data center, is surprisingly a good idea. Um,
Yeah, and I read your thing about what was it? It was like a number of petabytes. I can't remember what the number was,
it was big,
but
huh? It
it's
surprised me. It
huge.
surprised me. So let me pull that up. So
But
these were very conservative estimates.
I mean, there is a fallacy we need to avoid here, which is the usual, uh, 7 trillion is spent on, sodas every year. If we could only get 1% of that, we'd all be rich. It's the getting the 1% of it. It's, tiger stew. Boil
Mm,
water, catch your tiger. It's like, that's a big one. But um, the in terms of the argument, the I think the thing that is safe to say is there is a lot of latent technology
yeah,
that's doing square root
wasted.
of
It's wasted
yeah,
resource.
yeah,
And it's powered. It's plugged into the mains. It's secure because it's in the building. Um,
yeah. But also the marginal cost of letting a device that's otherwise sitting idle to do work is tiny versus the capital cost of getting it. So you get the capacity to have a phone, that's really important. But the marginal cost of letting something use your CPU while you're not using it, or even GPUs on the newer phones, um, is like, yeah, how would you even record it? It's tiny.
yeah. So it's really just sitting there asking to be used. I don't know if that's not really. I don't know what the word is for it. Like we know that that's there and that's huge potential, but that's not the primary thrust of what we're trying to get at. So this was really this was how the working went. I checked that up. There's around about 400, call it 400,000 working for the government in Tanzania.
By the early 2010s, though.
No, I looked up the because they dialed back a bunch as well, so it like went up and then it came back down and all that.
Ah,
Um, so it worked out these days around about 400k, and then yeah, like if it said like half, you know, half a desktop per central government employee. This isn't all the branch offices, and I think that sometimes the branch office costs can be significantly more than the central office costs in terms of computing hardware because it's harder to get to, so they need connectivity. They can't amortize their costs across the staff members. You've now got VPN requirements. There's like pain over the slowness of the network and all those classic
mhm.
satellite office problems. Um, but they still have, you know, plenty of compute, plenty of storage. Um, and smartphones. I mean, if every single one of them, the smartphone usage was like pretty. This was a pretty conservative estimate between 64 and 128 gig of storage, and that's only going to go up. especially if you had a working system like this, and you start saying, okay, now it's economical to buy the bigger capacity ones,
Right.
off you go, and then the 20 or 30% free on your phone. I mean, like, if it's a government phone, you could mandate it that actually you're only allowed to use like 20%, because what are you doing? Like, it's not your personal device. What are you storing on it? So these estimates are with like pretty paltry, very conservative figures there, and that still came out at 3.7T on the phones, which is whopping. Like, that's like SSD, battery backup, multiple redundant carriers, all these things, right? And desktop, 13 petabyte, like 13 petabyte. So if you divide it by, like, call it 4 for redundancy, or, like, you're still sitting on, 3 petabytes,
Well, even if you're out by an order of magnitude,
right?
even 1.4 petabytes that's expensive to
I
run.
know, man. A petabyte's a very expensive thing. And then if you also consider things like access time, like the data that's closer to the user is going to be quicker and easier, more responsive. It's going to feel better than the central server rack holding the big expensive enterprise drives.
Yeah, yeah, and also it doesn't have a big target painted on it when
No,
your
no,
next
and
door neighbor country decides to drop a bomb on you.
right, and also less sensitive to, like, natural disasters or power failure in a particular place. Like, the system would, if it was cell phones, it'd be like 90x% online all the time. Like, no one, the fire's never going to go out on that system.
Right, and the actual degradation is graceful.
Very graceful, very granular. So it surprised me, actually, the amount of unused capacity that was there. So,
Well, if you, I mean, we're talking about Tanzania here. Imagine applying that to, UK or Ukraine.
yeah, right. I think you can see from this that with just these back of the envelope calculations, there's enough to run a full city's infrastructure within its citizens' devices. Like, you
Yeah.
don't need these dedicated things.
Right, right.
And then if you also factor in if you change the workloads to be user centric, the performance demands of each individual device can far outstrip the requirements for each each single person can't really consume more than the resources of a single device, really. Like,
No, no,
yeah,
because you have to sleep. Number one.
yeah, number one, right? And so,
there goes 50% of the time sleeping and
yeah,
eating.
yeah, and then, like, the peak demand of each person is really not that high either. So, so I don't know what to do with that other than just, like, we should just keep going, because that's kind of that's the fabric that we wanted.
I've got it's going to be next week, but I've got lined up with data center guy.
Right.
We'll see. I'm not entirely sure how he'll respond, because basically we're saying you don't need to build a data center.
No, I don't think you should lead with that at all. I think that's very, very bad. I think what you want to identify is where is the shortfall in capacity. So he would have been through a round of budget cuts, downsizings, and all that, and then he's left with this project. So what you want to do is, like, well, what did they want more? Like, does the demand outstrip supply? Do they need more computing, more storage, more this, more that? So
Well, computers is a bit like motorways. You build more motorways and you get more motor cars. And what they want
yeah, there's a
is
word for that. It's
transactions.
like the something effect, the Keelson something effect. Like, It's just like
Something like that. Yeah,
it
yeah.
goes against what you would expect.
I was thinking about this yesterday in terms of a power grid.
Mm.
Uh, so if we take wind as uh, an analogy to individual phones, very small wind turbines um, can provide burst load, but if for whatever reason a network goes down, you still want base load. So the data center still seems to have a reason for existing in being the equivalent of a nuclear power station. It's like, hey, we're in the middle of winter, everyone's got the heaters on, and we've got a high pressure system over the top of us.
Yeah, because I mean, yes and no. You kind of want to figure out what is the forecast demand for these digital services over the next like 10 years. Like, what's the life expectancy of this data center? How long until it pays back? What what are the things that people are missing out on? That's what we want to try and target, because we're like, well, yes, we don't need a data center, but we don't also have our system now, so there's that. Data centers can be done right now. Um, the guy building and selling the data centers is never going to want to promote a product that doesn't need a data center. In his mind, data centers are essential.
Yes.
Yeah.
Yeah.
And you're not going to get very far if you go against that. So,
Yeah. Yeah.
what you want to talk about though is the demand that he's serving, and is he undercut by it, or is he are they going to be able to meet that demand, because maybe we've got this alternative system that can augment what he's doing.
It's
You
that
know,
augmentation is the important thing. It's
yeah,
like if you build a 1 megawatt data center, but you effectively get 3, 4, 10 times compute from
yeah.
that.
Well, another way of being able to pitch it to him is to say, look, you're building a 1 megawatt unit. The forecast demand over the next 10 years is 10 megawatts, but the budget available is for 5 megawatts. So now they're being very picky about what they choose to do. If you use a system like that, you could supply the needs of the 10 megawatt, and you could spend more money on the data center. Some stuff has to happen in a data center, so there's more chance that you can not spend it on this, in effect, wasted stuff, but you can spend it on the exotic stuff. Like, you're probably not going to be able to do training for an AI model on these distributed grids.
No, that would be
Maybe.
painful. That would
Well,
be.
there's an issue with the training where any piece of memory might need to be accessed by any GPU. And so the
Mm.
fabric that connects them is under significant load. And that's where, like, whilst we can run the inference on these edge computers or even on little clusters of them, the interconnect is, I think, prohibitive for training.
Mm.
So there's a lot of exotic things that a data center is going to be needed for, and the angle would be like, look, if we can work out a plan to meet some of the forecast demand that the government was budgeting for with this other system, then that frees up the capital to go build, you know, these other types of systems. And maybe because he's in competition, right, with all the other people who want to build data centers, and we're like, well, maybe, and this is a long shot because we don't have a working system, but you can see its feasibility. I think if we were in partnership with him, where we're actually cooperating on the hybrid like nature of it, where you know his data center was supplying this Fly.io like capacity, and augmenting this dark edge mesh, then that's a sort of a better deal. But
It is. It is.
you're not going to get very far talking about replacing him. That's all.
No, 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 absolutely not. This is why I was talking about baseload, because uh, you could have unintended consequences. I don't know. You could have everyone turning their phones off at an opportune moment. I don't know. Maybe they got
Right.
power outs,
Yeah.
and everyone's phone goes down. And the only one with dual redundant power supplies at the data center, you still
Mm.
kind of want that base load. But it's interesting that you're saying that you could build the models as part of that base load, but you're not having to pick up the inference overhead.
Yeah, that's right. Nor the storage. Um, so you can make them really just like they make the brain, and that's their job, and then the brain gets shipped out to
Yeah.
the edge.
I guess the only concern I've got with this is I think we're quite far from a national level infrastructure based on dark edge.
Oh,
Uh,
absolutely. That's even bigger, more of a problem. Yeah.
yeah. And so I think we can collect data
Have I
from this
misunderstood?
guy.
I thought you were talking to this guy about that, and I was actually trying to talk you down and be like, "That's not a good approach."
Yeah, no. I was talking about if I was to describe a system, it would be in terms of base load and surge load. And the surge load is out there on the dark edge.
Okay.
But what it does, having that surge load, it makes the utility value of what's been provided by his data center that much bigger. So it's the leverage.
Yeah, amplification.
Right.
Hmm.
Um, so it's not at all that he doesn't need to build it. It's the case that his argument for building it could be that much more stronger.
Hmm.
Just based on the possible.
Mm-hmm.
But it is if you if you expand it because phones are so ubiquitous. If you expand that to any kind of reasonably sized population, you're going to get the biggest compute power than anything that could ever feasibly be built.
Yeah, I think there's more compute power in the individual devices than there is in the data centers. I think, but
Yeah,
the individual devices can't concentrate. They
yeah.
can't bring all their resource to bear like a data center can. Like the
But also
density is the issue.
building a data center is a bit like building a nuclear power plant. I mean, some of the ones I think Microsoft. I was hearing. I don't know whether this is true or not, but one of the reports saying the footprint, physical footprint, is going to be about the size of Manhattan for the
Hmm.
one that Microsoft is planning on building.
Hmm.
That is a big deal.
Yeah, I know. And I just wonder how much of that load could be distributed out. I know that there's a bunch that you can't distribute, but how much could be distributed?
Yeah, but because it's so large, even if you said 10%, that is still a chunk of cash.
Yeah, right. A couple of blocks of Manhattan. That's still
Yeah.
pretty good. Okay, so I'll just lay out all the big bits that I had in mind, and we can figure out the best way to go through them. Um, the MCP server stuff, consensus,
Yep.
the ability to make cloud primitives, and what can be done with that, and then rolling through how individual services can be benefited from this architecture,
Okay.
and then OpenAI's new open weights model.
Yeah, I've only discovered that a couple of hours ago, so I've not really got up to speed with it. But it sounds like another remarkable drop.
It is remarkable. So here's it running. Have you seen it?
No, I've just been looking at videos reporting.
Okay, it's when you run it on Grok. Am I? Let me in. Let me in. Let me in. Dun 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 dun. Dun 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 dun. Dun 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 dun. Right. Write me TS function for a version of. What one do I want? Tendermint that is I always spell this word wrong. Quiescent. Go. Reasoning. Watch this baby fly.
Oh.
Full reasoning.
Oh. Okay.
And then it ends because it used too many tokens. So I always have to go submit again to make it carry on.
Yeah. Does my head in when it does that. How's it being throttled? Is it the context size or just
output tokens, maximum output tokens is 3,200. 32,000, sorry. So,
that's quite
paltry.
Okay. Yeah.
Yeah. But the point I'm trying to make is the rapidity with which it can output very good quality stuff, and the benchmarks that it meets are relatively on par with O3, particularly for logic and things like that. Now, why I make special mention of this model is I think this signals to us something that we kind of knew was coming, but we never really behaved like it was, which is to say that running cutting-edge intelligence at the edge is plausible. Now we have this model. We also have, if you'll note, we have advanced seed. So that gives repeatable results. Additionally, the architecture of Grok is founded upon deterministic operation. Like, hang on, if I can just get out of the console. They it's the design of the chip is about determinism. I can't find the exact place, but basically it's saying that the way that they've sped it up is by making the chip dedicated for running AI inference, whereas the GPU is about sort of graphics, but also the GPU is suitable for training, but the Grok thing is only suitable for inference. So you run it, and the way that they do it is they compile it to be deterministic, and so that's really good for us in terms of repeatability of what we're putting in, but it also runs on Fly.io GPUs because the model's so small. However, the cost, based on the estimates I got for how many tokens per second you could output on a Fly machine, the cost would be the equivalent of $16 per million tokens, whereas someone like Grok is able to sell you the GPT model for 15 cents per million input, 75 cents per million output, and they'll sell it to you at 500 tokens a second, which is like screaming fast and practically free. And so for now, it makes nothing but economic sense just to use Grok. Now, the reason I want to make a big song and dance about this open source model is that it allows us to provide fully transparent, repeatable operations that you could arguably run yourself, on your own computer, because a Strix Halo machine will actually run that model. And so we are, I guess we're seeing all the capabilities that we need to be able to build an attribution system that is repeatable or blockchainable are presently on the table. You've got,
how do they ensure determinism?
well, it turns out that all of the like TensorFlow based, PyTorch based AI models can be deterministic if you set up the runner right, because it is a deterministic thing ultimately. But where in typical usage, where without specifically tuning for it, where it becomes non-deterministic is that sometimes the runner will benchmark or look at how fast the inference is going, and then it will mid-calculation switch to a different way of doing the calculation. And so that can cause that switch, because it's measuring the performance of the current calculation, is non-deterministic. But you can set flags in these compilers that they've had for years. You can set flags in so that they run without that optimization. It's just like, no, pick this and run it. And then you get the same answer out every time, because there's no need to sample genuine randomness when you're running these models. So you can provide a predictable seed and still get the same result. Like, if I want to get 10 different outputs, I just increment the seed by 1 and then run it each time, and I'll get a totally different answer, but I can still repeat each one. And so what I'm thinking, or what I'm imagining now, is like, you saw how rapidly that reasoning kicks out. Like, it just floods out like a torrent, and when you see it in action, it's pretty thorough. So let me just run it in a bit more of a visually pleasing way. If I run it over here with these guys, then I open that up, you can see that it's very thorough what it does. And so if you were able to run this model and that was what worked out what you were going to get paid, you could feel pretty good about it. Like, it's, first of all, it's world-class quality reasoning. Like, the intelligence is up there with the best. Second of all, it's very thorough. Lastly, it's very cheap and fast, and so it can run loops repeatedly over and over and over. People can run bots against it to try and grind out a few extra % for themselves. Like, it starts to feel to me like we could run a genuine decentralized attribution system with this model. And if you can do that, you can do pretty much, you can run a company, or a mini company, certainly, with it.
Yeah.
And you can make that company transparent. And what's more, it can be blockchained.
Yes. And you can roll back and repeat.
Well, yeah,
So
the repeatability is the key to blockchaining. Like, that's the thing that lets you do it.
Yeah.
And then what another good element that lends itself to blockchaining is it's quite expensive. Well, it's not expensive, but it's non-zero. You know, like 75 cents for a million tokens is still not a zero amount. And
Yeah.
so that means that you can charge margin. So the miners are able to run this thing, and it's not like ridiculously expensive. If you ran it 4 times for a million tokens, you know, you'd be up for like $3. And that's enough that you can actually start to charge margin on, because you're also wrapping it in this embodiment. And, you know, margin means currencies, margin means profit. So it's like you would come to the chain to use this decentralized AI system. You'd probably choose the cheaper options, like making API calls out to Grok for a lot of your workloads. That's fine. It's still got the data on chain. That's fine. Some critical things that are really important, like the cap table, distributing payments, you'd probably want to run that on chain. It would only cost you like, I don't know, 10 times more to run it, which is a pretty good deal, all things considered. And now you've got this deterministic, repeatable revenue split.
Yeah. What are the benchmarks like?
I thought you'd never ask. They are excellent. So this model fits in an 80 gig GPU, right? So that fits nicely inside of the Fly.io GPUs, the Strix Halo, all that stuff. When it comes out, $120B with tools is scoring not that far below 03 with tools for code. Like 2706 versus 2622. Like the only thing that's better than this latest model is 04 mini with tools marginally, but
it's not by much though. I mean,
not by much, right?
It's 100, so it's
and Humanity's Last Exam, it's kind of like it beats 03 mini, put it that way.
Yeah. That's interesting.
It beats 04 mini with tools for Humanity's Last Exam. That's quite stunning, I think.
That is.
Health questions, it's pretty much up there with 03. Like, you probably, as a consumer, you'd be hard pressed to notice the 2% difference in the benchmark score in real terms.
Just marginal.
But I tell you what, you would notice is the reduction in cost by about what is it, like maybe 100, almost 50 times reduction in cost. And the speed, 500 tokens a second, you'd notice that. So I mean, Smash is 04 mini. Like, that's kind of wild. These competition math, I mean, back when GPT-4 was a thing,
it's diminishing returns on this
one, though. Right, it's all like 99.5. It's like, well,
I think as a metric, that one's kind of done.
Right, but if you're not scoring 90, 96, 97, you're not in the game. And that's a very good score. Like, that's a very good score. In fact, that's second highest in the competition math score. And again, it's just
1% of the other ones.
This is a good one for us. 67.8 in the function calling benchmark. Like, did it call the right function with the right parameters? It's better than 04 mini. So really, I do think that this model is competent enough to do the decentralized income things that we talk about. Like, it's competent enough to run a project conservatively. It doesn't have to be the genius that comes up with all the leading ideas and all that, but just to manage it. I mean, as we all know, everyone's got a pretty low opinion of managers. They're not stupid, but their role means that they have to be careful. This thing's very good at being careful.
Where's the arc here? Where's it going? Where's OpenAI going with this?
I think there's two angles you could look at that from. Um, the negative angle is they needed to take some heat off themselves, from investors, partners, all that. People are coming up
That
with money.
awkward open in their name. Yeah.
Not really that. More to show that when DeepSeek came out, if you look at the timing of DeepSeek and the release of this model, it sounds like DeepSeek launched. They went, oh shit. And then to prove that they were still the best, they made this. So that's a reasonable time frame for that negative story to have played out. I'm not saying that that's what happened, or that I even think that's what happened, but that's what the timing aligns with, right? And that they've sort of proven that, yes, you can do these tiny little models. Imagine what you could do with a data center size model that was that efficient or that smart.
Right.
So there's that. They don't make money out of this, but it is probably to defend their funding. Like people questioning, are you guys the best? And they're like, yeah.
Right. So it's a bit of a bitch slap to DeepSeek.
Or any other competitors that might come up against them. And then let's not forget that they're promising later this week a big release. Now, I don't know if that's going to be GPT-5, but GPT-5 is coming this month most likely anyway. So I don't know if it'll be like, oh my God, this just wiped the floor. Now we've got a new top dog. I don't know. But my honest answer to you is I don't actually bloody know. It seems like a weird move. I'm glad that they did it. It works delightfully well for us.
Are they bifurcating into the usual community enterprise thing with the next drop?
Sorry, what was your question?
Are they kind of forking into, community edition, enterprise edition?
Something like that. Yeah. Yeah, I mean, maybe they started seeing market share go to open models, and they kind of, because they actually they rely a lot on them being the best. They rely on that for advertising.
Yeah.
So yeah, I don't know. It's a weird thing to do. And then at the same point, like literally 3 or 4 days ago, Meta came out and was like, sorry, we're not doing open source models all the time anymore. We're going to keep some of it private. So what it could be is that all these guys in the labs around the place are recognizing that they have actually started to hit on some pretty serious progress. And they're like, oh, whoa, hang on. Like that's going a bit too,
It's an odd one, isn't it?
It is odd.
An open source model is like, yeah, sure, but open source usually refers to getting a community to contribute and improve it, and it doesn't really apply.
That's not open weights is not open source, because the training data and the methods is just completely hidden. But the nicest reason I can think of is that OpenAI genuinely is about being open, and they saw an opportunity to give something back or give something out to be open again, and they did it. And maybe there's an internal struggle of ideology going on inside that company, because we always see like burps and farts and little pops of the struggle that's
The
happening.
occasional person storming off and resigning, and
Yeah,
then writing to the
about
Wall
being
Street
open or
Journal.
not being open, right? And so this
Yeah,
maybe was a way of bloodletting or appeasing, but it didn't feel like an appeasement. It could just be that they actually genuinely want to be open, but they're saying, look, I know we said you have to trust us, because we know that we have to keep some stuff closed for now, but here's, we're actually not those guys. We are going to be open. Here's proof. Maybe.
I think there's a dash of scorched earth going on here as well, with the other open source models.
What do you mean?
If you provide an open source model that is so superior to other open source models, and you can throw that out, then you're kind of pulling the rug under the likes of DeepSeek.
Right, because
So,
there's no more
yeah,
benefit in them. Like if you just annihilate them so badly, then it's like, why would they try to
yeah,
keep going? Yeah. There's also the most Hollywood version I can think of is that they went to great lengths talking about how well they had trained the model to refuse to do bad things. So if you release the best intelligent model that's open and you are confident in its safety, you would prefer people use that than one that was lesser but had not as much safety.
yes, yeah,
So there's that. But and also there's a massive hiring fight going on in the AI world, and OpenAI got raided by Meta, and they're sour about it. So perhaps
mm.
the releasing the open thing is like the California way of sort of stating.
That sounds plausible, doesn't it?
It's
Because
like, come and work
above
for
us,
us because we actually are about open AI,
yeah,
really.
above a certain salary level, a lot of these guys are quite,
Past an amount, and they
motivated
start
by,
getting that they're
yeah,
like, I don't have to work again, but I'm going to choose to be ideological about where I
right.
point my brain.
So it does make sense.
So, but I would hate to think that it was just a publicity stunt. I would like to think that they did it on purpose and had always planned to, and that more will come. But ultimately, we have been given a gift. We have been given cutting edge AI that is repeatable and transparent and can run on the edge.
So I didn't see any benchmarks against Grok.
They wouldn't, because Grok would beat it.
Mm-hmm.
Because Grok beats O3, and O3 just beats OSS.
Right, right.
So Grok's still winning there, but Grok also hides its reasoning. I think there's a lot of value in exposing the reasoning fully. Grok can't work offline. This model can. And so you can actually, like, a Strix Halo device is portable. There are laptops out with Strix Halo in it. You can run this in the battlefield and it will work like as though you were connected to the Texas data center.
Mm-hmm. Mm-hmm.
Which is that's kind of powerful. That's kind of scary. So in my dream scenario, we would complete enough of this work that Tfue could deploy, or someone like Tfue could deploy even just a test case of Warfabric using a Strix Halo type of hardware, and then we'd use that to go to Tanzania and be like, look, battle tested, blah blah. Here's the rough conservative estimates of the latent resource that you are not using just within your government realms, let alone your citizens. Why don't we initiate some sort of a thing here? Like,
That sounds really powerful, doesn't it?
isn't it better to pay your citizens the money you were gonna spend on building a data center that was their tax money anyway? Isn't it
Or,
better
or,
to
or even just giving free mobiles every 3 years
right,
out to every citizen. Isn't it? There you go.
right? Like, there's even a way that you could imagine that if the agreement was to share some of the resources of the device, that you could make the device free and then export the service to either other members of the country or internationally, where you're
Right.
like, cheap storage, we got tech in our citizens' hands, they're getting better all day. While they sleep, the device works and earns and pays itself off.
Yeah, and the marginal cost to the user is zero for the device and de
Right?
minimis for charging.
Right?
That's it.
It's and charging's like incidental. It's like no one's gonna
Yeah,
hit you up for the like, mate, that'll be
fractions,
25 cents, thanks. Like,
especially next to the cost of a device.
yeah. Like, that's if you wanted your population to adopt technology, giving out free phones because you'd found a way to monetize it.
Yeah, or offset the alternative, which is a 2 3 year program to spend 10 20 million on a
Yeah.
data center, which is centralized in one big target on it,
Yeah.
and then you get the other benefits. I'm really hoping we can move on to this this solution.
Right.
This, this
This is this is this is the reason why I tried to make Interbit. Like
oh yeah,
that.
I was about to say is exactly what we were talking about when we're talking about IoT.
Yeah.
Push everything out to the edge and use all that spare capacity.
Mm.
Hmm. And now there's a model that actually previously we were talking about just running chains on devices. Now we're talking about running inference.
Yeah. This part, these open models lower barriers for emerging markets. So we could probably get some sponsorship from these guys if we could get something going in Tanzania. Because
Well,
that
I could take this to. Let me read that. Sorry, sorry to
yep.
interrupt there. These are more price to measure. Right, I could go to UK Gov. They've got that fund that's sitting there waiting to be pulled down. It's not large. I think it's only about 100 million, something like that.
That's pretty big, bud.
Well, yeah, but it's 100 million spread over God knows how many projects. But that is very much what the aim of that is. Basically, let's give a leg up to everyone we trade with, because then they're going to be good customers.
Is that the reason for that fund?
Essentially, it's diversifying from the US.
Divesting from the US.
Yeah, and instead, all these emerging markets that anyone with a brain can see, these guys are going to be accelerating with growths that have not been seen since
China. Yeah.
And so let's get in on the action on that one. We'll do it by helping out with grants. The grants have got to be matched with the country in question, and then I don't know what the agreement is behind because it's not public. But
Right.
essentially, yeah, there's UK money available. Pick it up, take it to Tanzania. Tanzania pays something, and then
Right.
you get a trading partner that's more wealthy.
Okay. I don't understand enough about international economics to really understand that, but
It's pretty smart. It's a pretty smart way of doing it.
okay. Okay. So I mean that's where we're at. We got it's open, we can run it, it's cheap, it's good. I think it's good enough to run ambient attribution. Like, it's better than us.
Yes, but also it's a lot cheaper than us and more trustworthy than us.
19% in humanity's last exam in an open model, when humanity's last exam was sitting on like 2%
Yeah,
2 years ago.
yeah,
So Grok's on 40 for this HLE.
yeah. Hmm.
I mean, Grok's my daily driver right now, but this thing is like for tasks, like it's so smart that you can just using it on a dumb task kind of it's trivial.
It feels like at the moment I still go back to um, beloved 4.0 for just stuff,
Do you?
you know. Yeah, but when it's like really quick, just give me the answer.
Right.
4.0 has replaced Google for me, basically.
Right. Yeah, Grok's
On
replaced Google for me.
Yeah, but well, Grok um, uh, churns more, and I usually go to Grok when doing more heavyweight stuff like the translation stuff. Grok is absolutely panning anything Gemini
Yeah,
at the
no.
moment. It still has that output window limitation though, which is irritating.
Right.
But yeah, I think 4.0 might get the boot.
Right. So what are we? I guess like are we still really just stuck waiting for me to get the software sorted? Like that's sort of
Yeah, sort of. Yeah.
fucking feels like where it's at. It's like everything we need is here.
Well, it's important to every now and again take a step back and try and
Yeah,
figure
I
out where
know.
the market is going.
Yeah. So let me just can I go into the consensus area of stuff because that's sort of been
Yes.
the biggest breakthrough I think that I've hit since since like 2013, 2014, basically. Um, so what I realized was that, having these like simple, brittle computing units and then running them with different consensus models depending on your use case is just vastly superior to anything else. It's dark edge compatible. It's got these great scale, performance, utilization, composability, all those things. I did some searching for. First of all, I'm convinced I know how to make a consensus API for us now, given the vast amount of time that I spent on the topic of consensus over the last few years. I can immediately be like, oh yeah, no, that's obvious now. That's like, it's a very simple interface actually. Uh, it's basically just that. Like it's pretty trivial. It's just the consensus function is just the next message that came in from the network, the state, which can be anything, and you return back the next state and the messages that you want to send out to the other peers. And what that means is that if you follow this interface where all the difficult stuff is handled by other parts of the system, like is the message signed correctly? Okay, yep, don't bother the consensus agent don't bother the consensus function unless it's signed correctly. Is it the correct format? Yep. Is it duplicated? Have we seen it before? Like there's a bunch of checks and things like, the network, did the connection fail? Are we late hearing from this node? Like all those network related things can all just be abstracted out so that the consensus bit is just this pure function. And then by making it a pure function, you can then do some really interesting testing on it because it's pure, so you can like rapidly grind it into all sorts of weird states and make sure that make sure that it follows the formal proof model correctly, and really just have great confidence that your consensus module works as advertised.
I mean, that's whiteboard, easy to understand, isn't it?
Yep.
Um,
And so there's a range of different consensus mechanisms that suddenly become within reach for us. So, internally we can just use like, non-BFT algorithms. And then for a consensus level one, like there's some good ones out there. It's interesting. I'm learning about new properties that I need because of this revelation. Like I need it to be a quiescent algorithm, which means that it turns out the Tendermint works on a clock, which means that the nodes all have to be running all the time and they're always heart beating.
mm-hmm.
But a quiescent algorithm, when there's no work to do, everyone stops. And that's what we need for serverless type of infrastructures like Fly, where if you stop, your server suspends, which means it costs you no money.
Mm-hmm.
So that difference is quite important. Like we don't want to be on all the time. We want to only turn on when there's work to be done and then go to sleep.
Yeah.
So yeah, it just feels remarkably simple to make consensus now, because we simplified the computing unit, and we simplified the blockchain down to this one hash.
Yeah. How's consensus reached?
It depends on the algorithm. So with this API, we can actually run several candidate algorithms, and you can swap them in and out depending on your use case. Consensus is reached when the consensus function says that it's now confident in the next state.
All right, so you can black box the actual algo.
Yeah, you can abstract it out, and it's like, well, the running system, it runs whichever version of consensus it was configured to, and that's that. And these come in as these pure, highly tested functions, and they just start running them.
Right, so the peers come back saying, yep, happy with that. Got it.
Yeah.
And that's all they do.
Yeah. Well, I mean, the underlying system is passing messages around that are of the consensus type that was configured. Like it might be.
Yeah, sure, but that's the black box. That's what I'm saying.
Yeah.
There's a black box that just basically says, yeah, for each peer.
You're right. Yeah, exactly. Yeah, it's like, hey, here's some messages. Don't concern yourself what's in them. Send them out to these guys. Okay, here's a new message. Okay, and then every so often, the black box says, new state. Bang.
Yeah.
And other times, the black box does a magical feature which says, Byzantine fault detected. Bang.
Yeah. That's remarkably simple, isn't it?
It's remarkably simple, and it damn well better be, because, consensus is maybe one of the hardest algorithmic problems in computing. It's a very difficult problem, and so keeping it as pure and simple as possible. What this API means for us is that we can actually compare multiple different consensus algorithms on the fly as they're being developed, because we can actually write them. Like Grok is able to read a TLA model and write it. And sure, a human has to go over it and check it. But what I'm trying to get at is not the fact that we can make consensus. It's the fact that we can have continually updating consensus algorithms, where we have like a dojo or a leaderboard, an arena, where, as the AIs get better, and they've gotten so good that it's hard to keep imagining it, they're going to get better, but they are. Mm-hmm. And, if we've got a very standard way to plug in and a very standard way to exercise and test the edge cases of each thing, then the AIs can help us make cleaner and cleaner implementations of the algorithms we already have, but also, maybe, now that it understands our problem more fully, eventually come up with new algorithms that are better suited to our diverse use cases depending on how you want to run your chain.
That's really interesting that you talked about AIs getting better and better, because previously consensus has been algorithmic.
Yeah.
It's not a huge leap to think that if you add in AIs, you could get consensus on a semantic level, a bit like, the Supreme Court. And consensus is a decision. And sure, you got minority reports, but, that body has come to a consensus on a decision, which is now written down. Let's move on. So there's something here using the same structure, which is basically asking, is everyone in agreement? Black boxed. The reason I'm going down this route is because, as you know, I've been thinking about translations, and translations are subtly different, and those subtleties are quite difficult to capture. AIs are very good at. Oh, is that a hand up, or is that
no, mate, sorry, I was just stretching my shoulder.
So with translations, what I'm doing at the moment is firing it out to a whole bunch of different models, and then going into another stage, which is let's compare those models, and the end goal is a consensus like thing, but it's a semantic consensus in that what I want out is a single translation that keeps in all the nuances and effectively sands down the rough edges of each particular model.
Right. So you want a reliable translation out of unreliable translators.
Yeah.
It sounds like there's algorithms in there.
It does, doesn't it?
Because I don't know if you can prove it or not, but it seems like there might be an unlimited number of consensus algorithms. It may also be true that there's an unlimited number of translation arrangement algorithms too.
It certainly feels like that, yeah.
It would be great if a really smart AI could come up with some theories to test on how you might go about arranging the current set of models, and also planning for the future. Like, what does it mean if a model gets above a certain amount? Would you arrange your algorithm differently? And then if that model could then benchmark and implement, then you start to get an arena going.
So the consensus is AI driven. The consensus black box is AI driven. It's like,
yeah,
you guys didn't
it's
really do
pluggable.
well
Like the key is to turn these hard problems that never end into API standard things that are modular. And so then you can improve the module, and you allow humans and AIs to focus on improving the module. You make a prize occur if you make even like a 0.5% improvement. You can get paid. Those types of things.
Yeah. And by making it modular, what you're doing there is anything new come along, plug in the new module, and let's see better or worse.
Yeah, that's right.
But you're still getting consensus, because the reason consensus is important is whenever there's something that may be argued about, then consensus is very valuable.
Right. Contentious, yeah.
Yeah, and contentious could mean who owns this Bitcoin, or it could mean which is the better translation of this poem.
Yeah, and that's an interesting one. I think the one you're talking about is much more valuable, because the one I'm talking about is mechanical, but you're now saying, well, you could apply that same theory into matters of taste.
Yeah, and because black box, it doesn't impact any of the, the superstructure around it.
Yeah,
What you're asking for is, you guys in this black box, do you agree?
Yeah.
And they go, yeah, brilliant, let's move on.
Right.
And what that allows is the black box benefits from any improvements in the models when you put an AI.
Right, and then you could also imagine where you could keep the black box proprietary and charge money for people to run the black box.
yeah, it could be a magic Chinese room, if that's still a phrase you're allowed to say. That goes back a bit, but like you just hand in a question and you come back
Mm,
with an answer.
mm,
How it's done, I don't mind, but it
mm.
doesn't break any of the superstructure around it. It's
No,
like,
that's right. So you really want the superstructure to be open and very stable, and then these modules, these gemstones, these brains are what gets swapped in and out.
yeah,
And
and you could,
like you could have hybrid solutions where it's human and machine operating the black box, but you're just like, we are the best, we benchmark the best, and here's our price. And if those things suit you, the quality and the price, then we have a deal.
yeah, yeah, and you could even imagine when how if it ever comes along, AGI fits into this. You could have a single AGI saying consensus is the AGI saying yes or no.
Nah, my view of how AGI is going to arrive keeps on getting refined, and I don't think
Mhm.
it turns up like that. It's not this thing that's right all the time, because in matters of taste, who is right?
Well, oh, um, yeah, that's interesting because then you're touching on attribution there. Right is the most fit for what people actually value and use.
Yeah, an AGI, I mean, if I was an AGI, I'd probably throw my hands up in despair and be like, these motherfuckers cannot be pleased, right?
Yeah, they're changing their mind all the time.
Yeah,
But the thing that is known is usage. It's
almost
like,
demonically. Like you put something forwards and you can guarantee that your first option won't be selected. Like it doesn't matter
yeah,
what you chose, it's going to be strawmanned. So,
right, right.
but there's always going to be room for a system that has deep context and deep private context. Like a bunch of highly skilled humans put together their taste selections between what different translated nuances mean, and then your black box runs over their proprietary selections, and that's how you generate world beating, most preferred translations. And
Right.
AGI won't have that. Like it just won't. AGI is not clairvoyant. It's not omniscient. It's just smart. If you don't tell it all the things you know about, it's be like talking. I shouldn't say bad things about it, but if you, it's like when people expect you to read their mind, they don't tell you what they want,
Mm-hmm.
and then you're just they expect you to know. It's gonna be like that. It wouldn't matter how intelligent a machine you had if you weren't given enough context. There's just no answering.
Well, it's the hidden part of the context that scrambles AI.
Scramble, yeah.
In the same way as, I don't know, talking to your wife, talking to your girlfriend, it's like, you say, what do you mean? It's like, you know what I mean. It's like, no,
It's
I
like
don't, because I don't have the
I
full context
look,
inside your head.
yeah,
And even if I did, I'd probably struggle. Give me
yeah.
a few years and I'd
I
figure out what you mean.
I refute it.
It's that hidden context is the
Yeah,
piece, but the
yeah.
black
So
box. Sorry, go on.
right. So really, there's a range of problems that start to appear for us now that can be API'd. Translations is one. OSINT
Yeah.
is one.
Yes.
Right. Like if we can get good at turning these problems into modularities, these are a special type of stuck, which is one that is well, a modular stuck. It's like it's like a junction point or a plug point where there are many ways to solve this stuck that are all have their merits, and so they need to be competed with each other to find out the best and to keep the best fresh. And that's a
Yes.
different kind of stuck. That's not like a my button should be green. That's like that's a componentized problem. Like that's a highly reusable, very valuable piece of software to make because it's
It's like a meta pattern, isn't it?
yeah.
What's the difference between an infinite monkey cage and an infinite AGI cage? Um,
So you kind of we need to be thinking about how to get these arenas up and get the plugs defined. Anywhere you can see a plug is good. Can I shift on to the next
Yeah.
thing which is about cloud architecture components?
Yep.
Right. Now, I apologize in advance for how fuzzy this is. There aren't existing good words to describe this way of building things because they're just not there. It is very tempting to go from this base unit of computing that we've got now, which is basically called a computer, for lack of a better word, a CPU, some storage, and a network connection. That's the unit. It is very tempting to try and present those units in ways that mimic the cloud without using consensus. Like,
Yeah.
right? But
Yep.
what I believe is the correct path, the path of CloudWin, is to say that I have noticed that I can combine these. I'm going to call them blockchains because I think once they have a consensus algorithm in there and they run on Git, I think that's called a blockchain. Is that okay?
Yeah. Yep.
So when you make these blockchains, you can now start to make many of the cloud primitives that are required to make exotic cloud services. For example, with a correctly designed Git repository and the appropriate naps, I can make a queue, a cloud queue, a Byzantine fault tolerant queue. And then I can also make a worker pool where I can manage the state of multiple independent high capacity workers using a blockchain to configure availability, to manage infrastructure, like spin up new workers, spin them down, all that kind of thing. And then I can connect that blockchain queue to the blockchain worker pool. And now I've got a pipeline for processing. I can do things like set up an API gateway where the API gateway has no smarts whatsoever. All it does is it takes incoming packets and it turns them into tool calls. So then it also does the reverse, where it will turn a incoming tool call into some other form of communication. And so what I can do is I can present port 25 for SMTP, and I can receive in mail packets. I can turn them into blockchain native objects, and I can put them into a blockchain that processes the mail. I can then trigger things from the mail, put them in a queue. I can get the workers to then process that queue, do some other stuff. And so what I'm getting at is that with these primitives, we can build up practically every service on offer at AWS. But underneath it all is this consensus module, which means that it can be fully transparent all the way down, and you can have full control over your data, and you can run it hybrid. You can run it on-prem, you can run it in cloud, you can run it between multiple cloud providers, you can migrate it at will, you can fork it, you can do all the blockchain things. But it's equivalent to AWS in terms of the cloud components.
Right. You're right.
That was actually easier to say than I thought it was going to be. I was struggling with that for a couple of days now. But that's what I'm getting at. With these primitives, you can build all the computing primitives and not lose the data cell sovereignty, the transparency, the Byzantine fault-tolerant failover, the scalability where you can like make it really big, really small, you know, like that raw performance that you get out of having like unfettered single SSD access. like all those things come with you.
Mm-hmm.
And at every single service, you can configure it at a granularity that is like maximum. Like, you can move servers to different locations, you can have different sized servers, you can have them shut down and turn off, you can have them sit on different bits of hardware, all that. And so that's one big part of what I see coming, right? And this is kind of what annoys me and freaks me out. I'm like, that's Dark Edge, but without the, like, that is that all that stuff. You could do Dark Edge AWS, but you could also do in data center versions of that would smoke like like the wind kind of smoke. The second part of it is the realization that what an LLM does for me, if I was to think about all of the software that was required to run AWS, and I thought about how much of that software could be replaced by an LLM in these blockchains. And then if I also thought, well, why not just give the LLM that's controlling the infrastructure and balancing it and all that, why not just give a version of that to each customer? So that now the customer doesn't have to build their own software to manage their cloud resources, load balance, failover.
Oh, I see what you're saying.
And like huge chunks of complexity just get peeled off and shed. Because if all you really need is this basic compute unit, consensus, and LLMs that manage all of the infrastructure, the IT management concerns.
Yeah.
And if you've got an LLM that does that, you might as well give that LLM directly to the consumer of the service, and they can just configure it arbitrarily however they want. And now you've cut out the devs that they were going to have to hire, or the DevOps who were going to have to manage this whole sprawling infrastructure, because now there's these LLMs that are purposely trained to do what DevOps did, but because they got this standard tile, the standard unit that's so simple and is used to build up these compound molecules of different cloud components depending on what you're trying to achieve, and it's all portable, movable, standard, like it starts to be a superior service that's cheaper, and has just wildly less complexity, and the reliability and the trust is fully transparent. Like, you can see, you can more than see inside it. You can control it. You can reconfigure the equivalent of the S3 buckets servers. You can move them around at whim while you sleep, no less.
Yes. And the search space of possible solutions using primitives is large. The search space of getting devs to do something to do a similar outcome is even larger, and that's fine.
That's the curse.
Yeah.
There are so many ways that you could do it. You couldn't possibly pick the right one by accident. You couldn't possibly pick the right one on purpose. And you certainly couldn't pick the same one as everyone else.
Yeah, and unless as soon as there's an improvement somewhere, to go back through your entire code base and make sure it's optimized for that, that's impractical.
Yeah, but that's very true. But there's also another layer, the biggest layer, I think, of unnecessary complexity and unnecessary developer involvement, is that anytime you try to automate something using classical code, you end up with a lot of code, because trying to capture all the possible... The problem with infrastructure is that it it touches the real world. And the real world has a very large number of possible states and eventualities and all that. And so if you are trying to use classical code to cover all use cases to make reliability appear out of automation, like not just automation, but reliable automation, you now tried to do the work of a consensus algorithm. The consensus algorithm is the one thing that can turn nature's natural devilness, natural randomness. The consensus algorithm is the one thing that can smooth it out into reliable. But if you tried to do that in code, you've tried to do some kind of a consensus algorithm, and you almost certainly did it wrong if you weren't doing it directly or cleanly, sort of like what this kind of interface is.
Yeah, absolutely.
But sort of more to the point, there's a lot of code that's been written to make decisions in an automated way and to also take configuration options from humans that an LLM can just, in one API call, replace all of that. That's the big chunk, I think, that we should go after, because that's the hidden chunk. That's the chunk that people think they need. They're like, oh, we've got automated this and automatic failover and blah, blah, blah. It's like, well, I got a bot. It reads the weather report. It knows there's a correlation between a tornado and you losing power, and we moved all our machines off about an hour before it hit. Program that.
Yeah, that's the thing. I mean, that's why the likes of Stuxnet could work, or any of these other hacks we had on the infrastructure in the physical world, because the physical world really screws up code.
It's not good for code. Code is not intelligent, and so you have to think of every eventuality, every possible system state, and who the hell makes a state chart to check their program has covered all options?
Yeah.
Not many, if any, right? But an LLM, it's just because it's soft and how it's soft and it has many goes. Like it goes, oops, no, oh yeah, better, no. Like...
And it will keep trying. That's
Yeah.
the thing.
Yeah. And especially if it's a problem space where, there is such a thing as good enough. It's not like you either score exactly or anything else is a fail. It's like most infrastructure problems, close works.
Yes, which is why you never get to, beyond 5 nines.
Right.
Because there's always going to be something.
Yeah.
But that something is vast. But the response is, then you need to get the devs back in, the sysop, admins back in.
Which is its own form of unreliability. It's like if your rate of change, your ability to patch a fault is so heavy, you should at least strip one of those 9s off.
Yeah. And availability also comes with response time. Response time measured in hours or days.
Yeah.
It's like, yeah.
So I guess that's sort of what I'd like to lay out one other example, and I'm really sorry to just give you examples rather than clean, finished, polished thesis or whatever the fuck they're called. But the last example of a collapse of code, I want to draw on how mail works. So you get the mail transport agent, which is the thing that pushes the mail out. Then you get the mail delivery agent, which is the piece of software that receives it. And then you get the mail user agent, which is the user's mailbox that fetches from the mail delivery spool so that the user can read the mail. And the exact example I want to call on is the complexity of running a mail server. So complex that you're recommended not to do it these days. I want to have a bet that this latest OSS model, with a little bit of prompting and tuning and tweaking, would pretty much nail spam rejection.
Mhm.
and it doesn't need all the connections or the subscriptions to Spam House, the fucking posting on this, that, the other thing, the something reputation score. Like, it doesn't need any of that. You just look at the fucking contents of the email, and this is an example that I'm trying to poke at where spam filters tried to interpret human context, what a human would think was spam, but they were unable to intelligently read the mail, so they had to look at all these cues, like where'd it come from, like I reckon that this OSS model would score very highly on one of the most difficult types of spam detection, which is when a really important email came from somewhere that looked exactly like spam. And that highlights the difference between when you and I look at email and I see, oh, it's in my spam folder. What the fuck's it doing there? Like, that's a really important email. But the machines had to be coded to detect that without being able to understand English. And so they looked at all their cues that I don't see, like the sender reputation, the DKIMs, the signature, all that stuff. And they decided that that was spam. And that's the dissonance between what I see and what the machines see. I didn't see any of that spam filtering stuff happening, but I just know it got it wrong.
That's a really great example. And the difference between spam filters and as they are and as they should be is the fact that I can open up my inbox and I can spot spam
Exactly.
a mile away.
It comes in and you're like, that is spam. And then sometimes good mail goes to the spam folder and you're like, dude.
Yeah.
But I bet you that these bots wouldn't get that wrong.
I don't think they would, because there's all sorts of cues. Again, at the semantic level, it's like, is this email trying to sell me something? Have I ever shown any kind of interest in buying this thing before?
And then, given if it was a bot that had access to your full context, like it knows everyone you've spoken to, all the questions you've asked about, and then it gets this email, it could be like, yeah, that's relevant.
There's something about information content here, isn't there? Because valuable emails have high information content. Invaluable ones are ones that the information content is so low you just don't care about them. You can spot that a mile away as a human.
Right.
If you can spot that as a human, you can spot that as an AI.
Right. So that's one example of where, like, we could deliver a pretty good mail service with very little software outlay. Huge gains in terms of transparency, so people can see where it's running and how it's running, and ownership of their mail server. They can pull it down local, all those things, right? And that's well and good, and we should do that. But the deeper thing, the deeper collapse that I want to put to you is that if I've got a mail user agent, like say I got Thunderbird or what do you use on Mac? It's like, is it just called Mail?
Yeah, it's Mail or
something.
So
yeah, and then people got Outlook, and then there's Gmail, and there's all these things, right? Yeah. And so those things are clearly best run as bots, plus some agents that can sort of interpret your mail and help you draft some things and sort out your inbox and retrieve information for you at a contextual level. And while you're talking, they can pull up emails and all that, right? So clearly AI integration with your mailbox, let alone your broader communication channels, is where it's all heading, regardless of what anyone says, right?
Yeah.
Right. So the key collapse that I want to put to you, which in terms of lines of code of software, which I think is like, anytime we can see huge swaying stacks of software that we can delete, that's a massive opportunity for us. And so the principle is, if I was making a mail user agent that was AI integrated, whoop-de-fucking-do. If we were making a mail delivery agent that was AI integrated so that it performed better, was cheaper to make, maintain, had like glorious uptime, had audit trails, all that stuff. That's very good. But why not combine the two? If the AI'd systems, like why have two systems at that point?
Right.
And that's the collapse that I'm trying to.
You're stealing context from one to the other. And
Well, you're losing it. If anything, it's being degraded. What's the difference between this open source model writing an email to my grandma versus it detecting spam email? Like it will gleefully go about either of those tasks and it will do it well. Why would I need two systems if it can do both of them?
Yes.
And so you end up with, sorry.
No, I was just going to extend on that. Because it's LLM, you can interrogate it.
Yeah.
You can say, I was expecting, this email in, and again, oh, sorry, block that, because it was
right.
poorly
But
worded
you can talk to the mail delivery agent itself because it's one and the same. It knows what it deleted. It knows why.
Yeah, exactly. You just had a very similar mail from this source, and it happens to be always on a Thursday for some reason, because that's when they do their mail run. Or it's always got the same typo in it. So you didn't respond last time. We don't care. Because the user interaction with it is also information, as well as
right. That's all very true, but that's not the collapse I'm trying to highlight. The collapse I'm trying to highlight is that we have, using classical software, built very complicated, intricate systems to try to be sort of intelligent, or to be more and more intelligent, by just really coding for all eventual outcomes and all this. And then what we did is, because the code complexity got so great, we segregated the systems so that we made like one piece of software that does the spam filter, one does the mail transport, another one does the mail user agent. But what the LLMs do, if we go right back to basics, is we can actually cut all of that. You can do a multi-stage cut. So you're not just, I think if we imagine that let's imagine we were software geniuses, right? And we're like, hey, we know how to make code for 10% the cost and blah, 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 blah. And we would be idiots to go after one piece of software at a time, because the software products, the software code bases of today are arranged in such a way, because of the burdens of the complexity, that's no longer necessary anyway. And so the intelligent move is to come in with pieces of software that cut across many of them, because you can't be touched as much. Like if you go after one, you're going to get pushback and you're going to get problems. And who's to say that your AI version of this existing piece of software would be that much better? Like, sure, it'd be cheaper, it might be better in some areas, but it's really about saying, why is that whole cluster of software components even there? How can we remove the whole lot?
It reminds me of another problem, which is also multi-layer, which I'll state as, I don't want my laptop to get a virus.
Right.
And there's many layers you could look at there. In terms of Okay, so you could do intrusion detection. You could detect when files that are not meant to be changed are changed. You could check for anomalies, but you'd also then have to have SIGs.
Right. So
And
there is a wrong way that you could do it, right? Like a way that has ever ballooning complexity.
right,
Then
which
every so often you can take a change of tack, like for example with iOS or the Android operating system, where you say, well, okay, we're going to isolate apps so that each app thinks it's running all on its own, and then now
yeah,
you just
yeah. But there have been attack vectors that have allowed VMs running on the same base 10 to infect each other.
correct,
Um, uh,
correct.
but the awareness of the different levels, cutting through those levels and adding those to the context inside of an LLM is, I think, similar to what you're saying about the emails.
Mm. There's ways to re-architect how the innards of the system plug together and cooperate that mean that you don't need all the existing components. So you don't replace the components one for one. You, if possible, replace all of them with one.
Or a small number of primitives.
Yeah, yeah, or small number of primitives. That's right. That's right.
Hmm. That's quite powerful.
Well, it's a lot of code to ditch. Like it's a huge chunk, and
Hmm.
you can get rid of like because people do things like they buy Outlook and they buy Exchange,
Yeah,
but you're like, well, why don't you just buy one thing?
yeah, yeah. Because really, what you're trying to do is to get one outcome, which is I want a message. Um, and it is remarkable that despite email being so mature and ubiquitous, I never look at it because it's just so shit.
Yeah.
Um, so it's failing despite all this complexity. It's an interesting idea, cutting through the layers.
Yeah, there's just I just like I guess my head's still reeling from it. The fact that you can actually build up all of these cloud components using these primitives in not very fancy ways. Like it's pretty straightforward. It's like it's a queue, right? But
Yeah.
like a first in first out queue, so like an ordered queue in the cloud that runs at scale, that's kind of hard, right? Like all of these systems are like as soon as they get to scale, it gets kind of hard because you've got synchronization issues.
Hmm.
And synchronization issues means somebody somewhere tried to make something like a consensus algorithm and may have not been explicit about it.
Hmm. Amazing with Dropbox. Fairly simple thing. It's like I want all my stuff on all the devices that I own.
Right,
Um, and yet somehow I've got to go up to the cloud, which I don't own.
right. I don't want that.
Yeah.
And then you end up with like you change something on your laptop offline, get to your office, change it there, and now you've got two files, and you're
Right.
like, well, what do I do now, right? But an LLM would know how to reconcile that for you. It's like, well, it's obvious what you tried to do.
Yeah.
Like I don't even need to ask you. It's obvious.
Yeah. Yeah. And this is an extension, not what you're talking about, but you could easily extend that to. I'm working on this file. Uh, the LLMs are dealing with files and syncing up files. Have a fork here for whatever reason.
Right.
You can talk to the LLM which you are dealing with in writing that file. Knows your intent. It's like, all right, okay, so yeah, I see the timestamp on this. I know the semantics of what you're trying to do. Here's probably what you're trying to do.
Right. Okay. So
Hmm,
that's kind of what we should do with this.
it's an interesting idea. Um, it's a big idea. Second one for this call. Um, I mean, if that were to arrive tomorrow, that would be awesome. But it kind of flops out of naps, doesn't it?
Yeah, well, that's the thing. Like, we're not even trying. We weren't even trying to do that.
Yeah.
That was an accident. We were just in the area.
We've got consensus, we've got repos, and we've got naps.
Execution or applications. So, like,
Right.
repo native applications that are consensus capable. So you
Yeah.
can execute them repeatably,
Yeah.
right? And now it turns out one of these applications is a world leading AI model now.
Yeah. Which is only going to get more accurate and more repeatable.
Yeah. Well, it is repeatable right now. Like,
Yeah. Yeah. Um, but there's multimodals and so on. Blah blah. It's just going to get better in
there's
terms
going to be,
of
yeah, like open source models will become more and more,
code
open
like.
weight.
Yeah.
Yeah. And so what? I guess is the problem. I did some looking into it, and I think the best company structure that we can use is a Series LLC in Delaware.
Okay.
And so what I think what we can do with that is we can use like Stripe Atlas to form an LLC, and that can be quite quick. Then we can update the charter, I think it was, or one of the operating agreement of the company,
Uh-huh.
and turn it into a
The Articles of Association.
no, it was something different. But either way, it's like the official document that can change it into what's called a protected series LLC.
I
In
don't know what that is.
no, well, neither did I until I went poking around in it. But what it allows you to do is you can create mini companies. Like you can create a series of companies under the umbrella of the parent
Uh-huh.
that are isolated against liability from one another, provided you keep the records separate and you're not, the regular rules apply.
Uh-huh.
But it means that we can make one company per project.
Well,
So
like a
one,
it's like spinning up a process, I guess.
yeah, it's like an isolated little mini VM that
Yeah.
isolates the liability risk inside that company. So people want to turn up and they want to do a venture. We're like, here's a limited liability series company for you, and the key bit is we're like, you can do anything you want, but this open source bot is in charge,
Uh-huh.
and it stops you doing anything dumb, but you can do anything you like.
Uh-huh.
And then that straight away, like the first, how many people have an idea for a company or whatever, but there's so much bullshit that they don't really know how to get started, and we're like, here's a bot, it'll do it all for you, basically. Here's a labor pool that you can reach out to. Some of these people have funding, like,
And I've not done a close look yet, but it sounds like that would not fall foul of securities after the new law that was just passed.
which law?
Um, the uh, the AI laws around. Sorry, it was not the AI laws. It
The
was
crypto
the
laws?
crypto laws. Yeah.
Well, so long as you're not raising capital from anyone but friends and family, um, that would be fine anyway. But what could be even finer is that we might be able to make that be publicly fundable
Yes.
if we structure that the right way. So,
Yeah. Yeah. Because it's all transparent. Um, I don't know. I've not looked closely enough at it, but
yeah,
it sounds
it
like there's
it's a bit of a
path there.
stretch. Like we'll need to do more research to make sure that it can actually be publicly fundable. But at the very least, it's privately fundable, and it's uh, a great way to do projects, I think. Um,
Yeah.
So like hot potato can just go in there. It's like
I
that's
agree.
just a project. And what's more, you can legally name them. Like you can call it, say, Dreamcatcher LLC dash Hot Potato Series, and that's a legitimate name. Like that's a you can enter contracts with that name because it's got the parent company LLC, and it declares that you're dealing with a series, and that's all you got to do to be like that's a legal entity.
Mm. Mm.
And then you can register for a doing business as title, which lets
Mm.
you you could name it Hot Potato, but it would be Hot Potato. It would
Trading
be
as.
Dreamcatcher
Yeah.
LLC doing business as Hot Potato.
Yeah.
Um, and then that gives us a way to start any number of companies. Stripe will let us set up individual accounts for each one,
Mm-hmm.
and
Hmm.
so we can basically have mini ventures, I guess, for
That's
no extra
what's
cost.
and uh mergers between these series.
I didn't look into that, but given that the register for the series companies is your own company records, you
Mm-hmm.
can do anything you want pretty much.
Right. Which probably means that you could spin up two and then dedupe,
Yeah,
merge.
yeah, dedupe, merge, fork,
Yeah.
all
Yeah.
those fun things. So I think that's
That
the way
sounds
to go, right?
that sounds pretty good actually.
That's exactly what we've been looking for. And then
Yeah.
I don't know if we can pivot from that into something publicly funded, maybe, but either way, we still need this, like a legal grounding thing
Yeah.
anyway. So,
If
uh,
nothing else, just to take payments.
yeah. But then, like with these new crypto laws, what I think's pretty good about where we're at is that we could have a running operating blockchain like way fucking sooner than I ever thought. But like when it's that's one of the key aspects of is it decentralized is does the blockchain run? And we're
Mm-hmm.
like, yeah, it does. Like, we'd need like a couple round of audits and all that, but because the system's so small, the code base is tiny, like it's not that we don't need an audit. It's like I'm like, well, what the fuck are you gonna fix? Like, there's nothing,
Mm-hmm. Mm-hmm.
like, there's nothing that I'm worried about that I'm like, if I miss something, it'll be like like a, I won't miss common faults because the bots would have scrutinized it. So they would
Yeah.
have picked up all the simple errors. And now it's like, well, is there an algorithmic error? Well, look, maybe, but uh, most likely not. Like, I don't, yes, we need an audit, but I'm not worried about being able to pass it based on the algorithm. Like, it's Git
Yeah.
with,
Yeah.
with,
Yeah.
you know, proven consensus. Like, um, and then I think more to the point, I'm able to, with that consensus API, I'm able to deliver us a consensus algorithm that I trust. Because even if like I made it and the audit came back with a few fixes and I fixed it, I still wouldn't really understand it. Like I'd be
Mm-hmm.
like, I'll take your word for it, but it's too big. There's too much code. But in this model, because I can
Mm-hmm.
like fuzz test it, I can, I can fault inject it. I can do all sorts of things on the algorithm. I'm like, yeah, no, I'm happy with that.
That's
I trust it.
interesting, isn't it? Because we with the our friend the Frenchman doing the formal um, proof. What we're really talking about is a fuzzy proof. It's like here it is. It's all there and it's
Yeah,
repeatable,
yeah,
and it is on chain,
yeah,
and so you can spot any oddness going on, um, and that would be at the primitive level far easier to prove formally than at the code level.
Yep. It might not need a formal proof. Like, I'm pretty sure it was me that even introduced the idea of us needing a formal proof, because I lacked confidence that we could design the blockchain to be safe.
Mm-hmm.
But as it turns out, the thing we're trying to design is a blockchain that can be modular so that it can be continually updated and improved as new algorithms are discovered by humans or machines.
Yeah.
And so a harder property to achieve is one of safety whilst upgrading. So,
Yes.
like your system better be damn simple and about as minimal as it can ever be so that it can have that upgradability proof or function, right? Like it's if it's made as modular, then it couldn't be the whole thing at fault. It must be, you couldn't make every single piece wrong. It must be one piece.
Yes, and the API structure that you had up on your screen there would be the layer that you look at, and so long as that piece could be proven, then inside the black box, you can give certain assurances by saying, "Oh, consensus might just be coin flips." What do we know? Coin flips are a consensus.
Yeah. Right.
But so long as those were publicly known, then you could give certain assurances.
And then, like, those particular modules, which are of special interest, those can be turned into arenas where competitions can be entered into to fault find, bug find, and improve. And more to the point, not that I've read those crypto laws thoroughly enough to pick them apart in this manner, but a functioning blockchain surely doesn't mean a formally proved blockchain. You know what I mean? Like, if we get it up and running, it's really about, like, does it genuinely run in a decentralized fashion? Yes. Can any one single party alter the course of the blockchain? Well, no. Is it safe enough that I can put my social security details in there? Absolutely not. Like, so long as it's running, how useful or valuable it is, how safe it is in the eye of the consumer.
Yes.
So it's okay to make a version that we're like hasn't been formally audited, has some known bugs, fails under these conditions. It's still decentralized.
Yes, exactly. And it's all down to your claims, which is really what commerce is about. Is, are you misrepresenting what you're providing?
Right. And if we can be like, hang on, we don't know of any faults, and then a fault occurs the next day, we're like, well, software, who knew, right? And then we fix it and we move on. But the point is that we can launch this thing, be genuinely decentralized, because we're not coming here with like a PowerPoint deck and a fucking wild idea. Like, we're turning up with some actual working software that was extraordinarily hard won. To strip it down this far was not cheap. And so what we're starting to see, I think, is a world where AIs will start proposing new solutions to famously hard problems, like consensus mechanisms, right? And so long as we've got a system in place that is able to capture or instantly benefit from those types of modular upgrades, we will rapidly grow, like rapidly. And if you think that using our own bots pointed against the code base of the chassis they sit upon, continually grinding over, looking for faults, looking for improvements, coming up with ideas, humans chucking ideas and questions and things in there. And it's like now there's like multiple agents, multiple people all trying to improve the chassis and the modules. Like, it couldn't not get better.
Right.
So all we got to do is launch with something that sort of works, and the environment that we've constructed for ourselves here says that pretty much you can guarantee that improvement will occur like on the same day. Like, and that's what matters. Like, how often does Ethereum upgrade? Well, they're doing pretty good, but man, it's pretty painful and it's pretty slow.
Right, but you also got the guardians of the LLMs, which you can state that they're there, and here's the prompt, and here's how they interact, and so on.
Right. Right.
Which is another level, because someone reacting to code, something goes wrong, right, we're going to get our devs in, as we were talking before, as opposed to LLMs automatically go, well, that was odd.
Yeah.
I'm going to stop that.
Yeah, that's right. That's right. It's like having a human at the helm all the time.
Yeah.
Right? And I'd even argue to you that because Grok is deterministic, and because I've exposed that seed parameter for the OSS model, that it is entirely acceptable to call something decentralized if, say, 4 independent parties all run the software and all make calls to the Grok API. Or because the OSS model is hosted upon multiple providers, you could say, oh, well, Grok could turn around and thwart what the results were to favor themselves, and so therefore it's not decentralized. Well, look, the DNS service could thwart what it said too. Like, no one...
But then surely you just abstract into a number of models, and you get some kind of consensus amongst the models.
Or providers, right? Because the OSS model is made available by multiple providers, not just Grok. Right? But ultimately, we now have the power to be able to run it on our own hardware. So you as a operator, a validator, you could choose to run this anywhere you like, right? You just got to give it, all you got to do is buy, like, a Strix Halo machine is $2,000. Now you're a validator. Like, great. So, what am I getting at? Like, we've had some unexpected massive wins here, but everything we need is sitting there. What now? Like, I'm like, it really kind of comes down to, I gotta get this piece of software going. But
well, again, and it's good to hammer at the architecture and think, well, is this all, or is this too much? And we keep on coming back to repos, consensus, and LLM wrap naps.
Yeah.
And it's like, there's your primitive. If there was a new ISO OSI layer model, that's, one up above 10.
Yep. So I think those are, you'd call those your virtual, those are all virtual components, because then there's like specifics, like which network protocol are we using, which, all that type of stuff. But I think what I'm trying to get at is that, having stumbled upon this compute tile mixed with what feels like trivial consensus now, has made me, like, I question, remember I was like, is it worth making a blockchain? Like, do we need a blockchain? Because we kept talking about LLM features.
Yeah.
Right?
Yeah.
And then I kind of lost sight of, like, I'm like, well, what does the blockchain really give us here? And then I think it also became, because we're calling out to API providers giving us running black box inference, it sort of felt like, it's like, well, that's not what I would call a blockchain, because, I don't control it, right? But now with the OSS model landing, I'm like, oh, hang on. This blockchain is actually extraordinarily useful if you design it in these cloud primitive ways, because it gives you, it's not about the sovereignty necessarily, although sure that's great. It's about the portability
And
of it.
it's the inheritance of, the benefits of sovereignty and provenance.
Right. Right.
Um,
And then if you also mix that with something that we did nothing to make happen, which is to say these crypto laws that have made it clear what a decentralized blockchain is and have made it clearly not a security if you trade assets that
right.
are intrinsic to that thing, then we're like, hang on, we can run decentralized income. We can run companies that are guided by a very smart, decentrally run AI model that tells you how much you're going to get paid and is beyond reproach, as no one party can control it. So it's not a security. So now you can pump money into it. You can pump public money in. You don't need a stock exchange,
Yeah.
right?
Precisely.
You got this fucking thing sitting there, and it's like, well, have you got USDT? Yeah, all right, send it
Yeah.
to that decentralized company.
And then in the Delaware series model that you're talking about, we've got the grounding event that
Yeah,
makes it real.
right. Now we can touch real money, fiat money, bank accounts,
Yeah.
and we've got
Or,
this.
or anything we want to do.
Yeah, we got this layer that's protecting. Like our business becomes making bots that don't do dumb shit, like they don't let you say it's like spam protection but for financial systems.
Yeah.
Like you can't make a wrong payment, you can't not file your taxes, like all these things.
Yeah. Yeah. It's all taken out of your hands.
Oh
And you can
man,
spin up per project. I mean, that's pretty powerful, isn't it?
oh god, I wish this thing was here right now.
Yeah. Look at that, man. We've got so many use cases for this floating around.
Right, but it turns out that the blockchain thing's pretty important because the blockchain thing lets you make a mini stock market because of the new crypto laws.
Yeah. Yeah.
That's actually aside from the fact that it lets us construct competitive software with fractions of the cost or fractions of the software complexity, like that's separate, but it also allows us to make a stock exchange.
Yeah.
This is a really, I'm embarrassed to ask this question, but how can we make it go faster?
We need to get the substrate up. Consensus repos, naps, wrapped in LMs.
I am currently, I'm struggling on getting the MCP interface going. I have been through, if you get a chance, you might find it fun actually. You can go to my repo here, and you can, all of these notes I take are public, so you could scrape them and do some bot analysis on them or concat them or whatever. But this is basically all my thoughts, right? Everything that I think about and work on in a given day. And I'm like, if you see the word MCP like littered all over the place, it's because I'm trying really hard to figure out how to match MCP up with Artifact. And I think I got it, but man, it's kind of a bit of a mind bender. So is it correct that we still want to have MCP as the base protocol between NAPs?
Oh yeah, I refer to a conversation about 4 conversations ago. We went through that, and nothing's changed this side. Seems
Okay,
like
so let me can I run through then? How are you for time?
I'm running short. Probably 10 minutes.
10 minutes. All right. Can I go through with you how I have broken up the components of the MCP system.
Mm-hmm.
Yeah. So the way I look at it is that the NAP package format, another way to name that is the MCP package format.
Yep.
And so with a NAP, if you have a NAP, that's all you need to start an MCP server.
Yeah.
But
we talked about the equivalence of NAPs and MCPs before.
well, we did, but it wasn't. I hadn't sort of related them together like that. So the MCP server is the running callable instance of the NAP. The NAP is the application package. The MCP server is what happens when you fire it up.
Yeah. Okay. Yeah. That's more precise. Yeah.
More precise. Yeah. Well, that's what it's been all about for the last fucking 5 days or some shit. And then the repo is the file system that the MCP server is running upon. And so you could run an MCP server without any repo, but it would not have any persistence.
You'd have the thread persistence inside the instance running, but when the instance
No,
disappears,
because it wouldn't have any memory. It's got nowhere to store anything.
Okay, let me think through that. I don't understand. So the NAP 200 LLM as a package is instantiated on an NCP server. It doesn't have a repo, and it asks 2 questions. Does the second question know about its answer to the first question?
No.
So it forgets everything. So
it does a tool call, and then it gives you back the answer, and then that's it.
Right. Okay. All right. Right. But if you can stash that in a repo, then you've got something thread-like.
Yeah, that's right. Yeah. The repo represents the storage layer or the disk component of it. So the NAP represents the application code, and the server represents the CPU and RAM, and then the repo represents the disk plus the network in a way, like the ability to talk to other things.
Say that last part again.
The ability to talk to other things, because the MCP server's a bit misleading in the way that we're going to be using it. Is that when you are a client of that MCP server, it also doesn't have any network abilities other than talking to you, which isn't strictly speaking network, because you have to be standing on a repo to even talk to it. But you can talk to it. It can't talk out because it doesn't have a repo. The repo is how the comms happen.
Gotcha. Right.
And so I am sorry that I don't have, like, we're using repos in a weird philosophical way, like they represent state, identity, network. They can store computational snapshots. They represent state. They represent a lot of things. We don't have a good word that actually, we call them repos, great, but there's no like one word that sums up what that is. But it is, substrate is pretty much what it is. So you can have a pure app that's like got no substrate, so it can't do any long lasting things. It can just like calculate something.
Things. It's like a command line. Boom. Tell me the date.
Sort of, yeah, things like that. Things like that. So what I wanted to show you was the relationship between the NAP format and the MCP format, so that I could explain to you the mapping that I have planned.
Okay.
This was a sketch of the NAP format.
Yeah.
Now you will recognize tools because obviously that's
Yep.
there's no debate about tools, right? MCP tools and NAP tools map 1-for-1,
Yep.
no contest, right? We had this key here called agent, where agent was how you would represent the way in which you could make bot-like calls
Yep.
into it. Okay, so you just hold that thought. Over here, the equivalent is prompts. Prompts.
Okay.
Prompts.
How do they use prompts?
And what's
Prompts.
the definition?
Prompts represent structured templates that define expected inputs and interaction patterns. So they allow you to do things like provide they can provide multi-shot or mini-shot prompts. They can have a sys prompt.
It sounds like a metasys prompt. In that, by prompt, typically that is referred to as a user input in a thread. Sysprompt is the context, which is very close
basically
to the definition
what
there.
what I think they mean for prompts to be, or what we could use prompts as more specifically, is all the information you need to define a bot.
Mm-hmm.
That's what I think prompts is. And so what we were proposing in our NAP package was agent, which was all you needed to define a bot,
Yes.
right?
Yeah,
And
yeah,
so
'cause you say you have these tools available.
Yeah.
You use
Well,
model.
yeah.
You could do multi-shot there if you want. Don't really care. It's a
Right.
black box that gives you back.
right.
That's
And so
the
when your use case of creating a bot, using a bot, I was envisaging that as your bot is writing a NAP file, where the NAP file contains the definitions of the agent prompt, the tools that it can use,
Yep.
all those different things, right? But
Yep.
really, I should rename that to match with the MCP language of prompt, because that's what they do. That's what it is.
It says who controls it? User controlled.
Yeah,
it's not really user controlled because it is the at rest version of.
Yeah, that's the thing. Like it really is the at rest version. The way that they intend prompts to be used is like this. So they would expect that the client asks the server for the prompts, and then it gets a specific prompt, and then they expect the client to then run it using the LLM that the client has access to. So it's really fetching the bot definition and then running it. And that's what we're doing.
What's the definition of a client here? Is
A
it
client
server, as in running instance. The thing is called the running instance to be.
So
from at rest.
you, from your point of view, you are the application host, and the application host, if you want to call on an MCP server, you create a client, and the client connects to the MCP server. But the key component is the application host. That's sort of where you're standing. That's who you are.
I see. I think they've chosen. I think they're over-indexing on prompt there, which is not very helpful. But that being said, if we go, and I really think we should go down the MCP route, then aligning our definitions with theirs would be make sense.
Well, I think so this is what's taken all the time, right? Is me going through the NAP format and aligning it with the MCP format, and it aligns there's no faults that I can find. It just took a while to see what different parts meant and how
Yeah.
to do like edge case controls of it. Like, is there a tool call that now changes the client? How do I browse for new naps? What is the external MCP server, the one that uses the real internet to talk to the clients? How do I tunnel through that to open other MCP clients? How do I expose an internal NAP on an internal repo to an external LLM by, like, how do I make it so it can be tunneled in through that external MCP gateway? Like, there's a lot of different, I have to consider all of the different use cases. Otherwise, it just, like, it's easy to make a dorky choice and do something that I don't know what I'm doing, and then it, like, looks weird, and someone asks a question, I'm like, mate, I don't know.
Right, and that mapping I think is quite important. So what I'm
That's
hearing
the
from
whole
that
that's the whole
is,
trick, man. That's the whole trick.
yeah,
Mapping naps to MCPs and getting all the subtle fucking things right. Like, a server is a running instance of a nap. A repo is the disk in the network. Like that. Those were not obvious to me at the start. Like, that took a lot of.
yeah, I think they've been a bit free and easy with their definitions there. Well, no, they've
No,
been
they're allowed
clear
to
with
because
they're over-indexing on words a bit.
they're
I think
allowed
that's
to because they were simply coming at it from a necessity point of view, a simplicity
yeah,
point of view. We came at it from trying to blockchain these things, and we got this package format that was, we were like, we can make the tool package format be generic for any kind of tool, and then it actually, oddly, I'm still not sure why, maps exactly to the MCP specification.
well, if you were to look at the definition, the format of a NAP now, and Prolog style have uninstantiated name labels, would it map
Yeah,
over?
yeah, you would. Yeah, 100%, 100%.
Oh, we're in a good place then. So then it just really comes to wrapping your head around it.
Yeah, it's figuring out which things map where, and there are some fundamental, like, hard things I really struggled to do, right? Like getting streaming in the AI coming down in the artifact calls. Like, I sweated for that one, and then I had to find a whole new way of doing it because they have this convention where it's the tool call doesn't stream. It's like tool call in, response back. But I need streaming because I'm not living without that. So I found another way around it to do it as like a side channel, and overall I think it's better.
So how
But
close is the overlap? I mean, what does artifact map to in MCP world?
artifact, which was the object that you got when you were programming inside of a NAP or when you were in a web browser on the outside, that one the piece that I showed you where I could do like artifact.files.read and then the path and it got the file back, that is actually a collection of MCP clients. So like the files portion of Artifact is the MCP client for the NAP that does all the file system operation, because as you recall, I labored hard to make all of the system calls of Artifact be NAP calls.
Yeah.
And
Yeah.
I wasn't, at times I was like, why am I doing this? This is so hard. But now it's because we can't have introspection or this ability for the bot to look at itself and understand how its own innards work if we didn't do that.
Yeah, but it
You,
doesn't sound like there is a correlate or a similar item inside the NCP format. So
there is. Well, the MCP format doesn't concern itself with things like introspection, reflexivity, all those different concepts. That's free. It's very free for the implementer to choose to do that.
yeah, but there's not a one-to-one mapping
of Artifact to an MCP primitive concept?
No, because Artifact, I started thinking about it like, do you mean the Artifact client that you work with in the browser, or you mean Artifact the substrate?
Artifact the substrate.
Artifact the substrate turns out to be best thought of, I think, as an MCP hypervisor. Where
Right. Oh, right. Okay. So
it's
have they
capable.
defined, or is that something?
Sorry, what's that?
Is hypervisor a term that MCP uses?
No, because they don't concern themselves at all with how you run the server. They just
Right.
give you some examples. But really, Artifact the substrate is like a firecracker host, where it's got like thousands of MCP servers that it can instantly fire up and start to respond to client requests.
Right. So it's not a straight one-to-one mapping. It's a 1 to n plus 1.
Well,
or whatever,
the
1 plus n.
the interaction or the network of repos and the interaction between repos and naps is outside of the MCP specification.
Mm-hmm. It's at a higher level.
Yeah, it's outside. It's
Yeah.
like, but the protocol maps very well with, because it's centered around tool calls. Artifact was built centered around tool calls. And then you and I recognize that along with tool calls, you also need this bot capability, which can take natural language in. Of course, you need to configure it. You need to say what model it should use and what parameters it should use. They think the same. They are doing the same. Like when the prompts come in, it sends back config. Like it sends back things like you can send back, well, you can send back arbitrary data, but they encourage you to send back things like what model do you recommend to use, what what starting prompts, what role should it be, like it's effectively the same thing that we wanted to do.
It's a subset of what we want to do.
Correct. But I think if we rejig what we've got a little bit to slot in exactly with MCP,
Yeah.
and then I'm pretty sure I got it right, but please forgive me if I need a second stab at it. I think I got the integration right. Somewhere out there is a correct integration. For the sake of speed, I'm going to just go with the one that looks mostly like it and then YOLO the rest. So if we slot in neatly with them, we can stabilize on them because everyone else who uses them understands who we are.
That's the big win, isn't it?
Yeah.
And then if we layer on, if MCP is a subset of what we do, anyone who wants to interact with what we do.
Yeah. And so one of the ways that we can present ourselves, like one of the first cloud services we want to offer is we are an MCP hosting service because Artifact is MCP Firecracker.
Yeah.
And so if you want to run your MCP server and you don't want to have this dorky ass connection where you got to fire up your console of all things, run an npm package that you don't trust on your machine, and then connect your LLM to it and give it goodness knows what permissions. If you don't want that, or you want to distribute your MCP and charge money for it, or at least have uptime, I mean, come on, then we are your guys. You package up your MCP. Right? Because MCP doesn't have a package format. They didn't describe that in their thing here, but we're saying we've got this package format called NAPS. We can rename it, whatever. Package up your MCP server, push it to us. We will run the MCP server for you.
Yeah.
Because that's what Artifact is. It's an MCP runner.
Yeah.
It just so happens that under the hood it's running repos and branches and it's got this blockchain ability and all that, but
if you're coming in at the MCP level, you don't really care about that. It's
You
just
don't really
giving
care, no.
additional bells and whistles, and that's
Yeah.
very nice. Thank you very much.
Thank you very much, right? It's like virtualized, blockchainable, because the virtualized instances can run in lockstep. MCP hosting.
Yeah.
And I think that's a big deal, personally.
I
Like,
think so as well.
because there's
Yeah.
I haven't seen an MCP hosting service because I haven't seen an MCP package format. And now we've got one of those.
Yeah, because everyone's like, growing their own or rolling their own.
Well, it's also
Um,
mutable, right? Like everyone's thinking of these servers like a traditional web server, which is already a horrific fucking thing. Like you can't make a package for a web server unless it's a Docker container. So you're
Mhm.
either packaging it in something that tries to emulate an entire computer,
Mhm.
or you're breaking it up into little modules that run on like only on Node.js. There's nothing in between. And we're able to say we think we have that package format and we have a hosting substrate that runs it. Big bonus, it's like blockchainy, but from our point of view, that's good because it's damn simple. Like it's
Hmm.
tiny, it's reliable, it's cheap, it's all those things.
And also, it's expedient to us to offload to NCP in terms of clogging into other people's work.
Yeah, because you can if you ran your MCP server on our substrate, you can go into Claude right now, the Claude desktop agent, and you can type in our URL and you can connect to an MCP server running on our infrastructure.
Yeah.
One of those servers can be
Which
the
is
App Store.
pretty fucking cool.
Yeah.
Yeah.
You can have the App Store MCP that
and
helps
also
you
you can-
browse for other MCP servers that we're running.
Well, exactly. That's what I'm saying. At that point, you've got Lego blocks.
Lego blocks, yeah. Big Lego blocks. And
Yeah.
so, yeah, I honestly think that we're there. Like, I can see the finish line. And I honestly nearly I was like, maybe it shouldn't be a blockchain. Maybe we're wasting time with being a blockchain. And then it was like, MCP, we should look into MCP. And then that sort of faded off. And it was like all these things that on their own aren't significant enough. But only now that they've all come together, it's like, oh, that plus the new laws in the US about what decentralized chains can do. It's like, oh, that's
I think what's happening at the moment, and I wouldn't beat yourself up too much about it, is we are, in the whole landscape, is developing new local minimas, and
yeah,
we've by combining those, you get deeper local minima. It's more stable. But yeah, the landscape is getting potted by new local minimas.
yeah. Like tier 2 is emerging now.
Yeah, this is tier 2.
This is
It's
tier
exactly
2.
this is what we're talking about.
Yeah, and this is a
And,
tier 2 hosting service.
Yeah, and tier 3 should be shitting their pants.
Yeah.
But,
Plus, like, don't forget, we can call back out too. So if there's any other MCP servers running somewhere, because some people have set up like strong ones, like if they've got like the Stripe MCP server that you can do stuff to do with Stripe, we can proxy through for you and we can call that on your behalf. Like we are the internet. We can call out as well as receive. So we're actually got quite good Stripe capability.
yeah.
Yeah. Anyway,
What was the question?
how can we go any faster?
How can we go any faster?
And I'm embarrassed to ask because I think it's just I work my ass harder. But
I think we can't go. Well, let me be typically Scottish brutal about it. I don't think you can go any faster.
that means you can go faster.
I can.
I know.
I've got capacity.
I know how you can go faster.
How?
I think what we just sketched out today represents our landing zone. Like we're about to touch down.
Yeah.
That means that there's a bunch of other prep work that needs to happen, like creating this company, setting up the series, figuring out like who the concrete clients are, not in terms of getting them to sign up or anything, but like what are their requirements in terms of HIPAA, GDPR, what sorts of trust, because we really want to swing on the sovereignty thing, right? So we need to find people like you've been doing that have these like extreme sovereignty requirements. But, like, have we got everything in order? Can we, what data center are we using? What processing agreements?
What would be probably quite a useful use of time is to correlate, because the hopper is large. Spent a lot of time talking to a lot of people.
Yeah.
I can correlate down to what the commonalities are.
Right, and then find out which ones are best benefited by this landing point, this terminus point that we've just seen. Like, this is where we're landing. We're landing on this. And
the common what's the best way to put this? The guys I'm talking to are the decision makers, and they're not that technical, but they know what would be acceptable.
Right.
And so if I said MCP to these guys, in some of the more advanced conversations, I could get down to the techies or the CTOs and that sort of thing.
Right.
But mostly it is the requirements.
Okay. Well, do we have those documented in some form that we can actually pick out which ones are most benefited by our technology and most achievable by us, and also have a price attached to it as well? Like, there's a bit of screening we can do.
There. Yeah, there's a few steps there. The first one is documenting what the capabilities are that we just discussed, what the emergent capabilities are, and then what are the required capabilities, and see what the gap analysis is. The cost, I could give it a shot, sure.
Give it a shot, right? Just pencil in a number next to it and be like...
Well, I could probably give a shot at what is an acceptable cost as opposed to...
Yeah. And then you and I need to then weed through that list and go through which ones are actually practical to attain, and I need to give it an effort score. Right. Because if we arrange them in the right sequence, we can hit several at a time, because we're like, these three need this one feature. Before, I know you're tight on time, but I had a very interesting call come in. And I proposed to them, based on their environment, the most horrific ergonomic package for our agent system that I could imagine. A Microsoft Teams bot.
But it chills on my spine.
Yeah, well, fuck. You won't be the one that has to build it. So, but anyway, looking into it, it actually I found a way that I can get out of that infrastructure, or out of that, I'm not even going to give it the dignity of calling it infrastructure, but I can receive individual audio lines from each participant in a meeting.
Well, that's kind of cool.
Yeah. But the reason why I'm excited about this is, so this company is deep in the Teams infrastructure. They use Teams to do one-on-one calls. They use it all, so there's no getting around that. However,
some cost,
but also cost of switching. However, that's similar to a lot of other companies. And if we say to ourselves, okay, we're making agents, we're making generic agents that can take text in, files in, images in, live streaming audio in, multi-participant live streaming audio in, maybe audio out, then sure, it's one thing to add it to our own platform where you can come and chat and socialize and whatever and engage with these agents. But it's a small ask, really, to put a facade on it as any other type of platform bot, like a Telegram bot, a Discord bot, a Teams bot. It's the same agent. And it would be able to see the same company context in the background, all the emails, the file server, the knowledge base.
So what's the breakout point there on Teams, for example? I assume it's just an API. An API would be a tool. Would be an app.
Well, it's a bit special because, well, end of the day, what it comes down to is an API connection to the Teams infrastructure, and then our agent pushing and pulling the levers on it. And
Right.
so,
It should just be. It's just an app. It's just another app. It's the
well, it's not
in.
really a NAP because it has to integrate with something that's not very friendly. But
Yeah, it's an external tool call, the API call.
right, yeah, for Teams it's a little bit more involved. You actually have to run on the Azure infrastructure on a Windows Server machine to be able to access the audio lines. But be that as it may, you end up with ultimately, as you say, an API call in and out, and we can transform that into NAPland, and
Right.
that is a
Right.
NAP.
And
Yeah, you're right. That is a NAP.
uh, so if we could present, you're right in saying switching cost. I said sunk cost. That was the wrong one. But switching cost is the biggest problem to
Yeah,
getting
but the
anything adopted.
key I've realized, the big key for us is what we got to present ourselves at is we come in at the level of the humans. And so turning up as a fellow teammate in the Teams call is the perfect spot for the agent to land because it turns up looking like a person. It can do everything a person can do and more. You can email the agent. You can WhatsApp the agent. You can Teams call the agent. You can use the web browser,
Yes, absolutely,
right?
absolutely.
And then now we've got this thing, like if I do this thing for this one company, we can do it for like anyone that has Teams. It's like someone call the Teams guy, and then in comes this agent, and that's how they consume our products and services is through this automated agent.
Without having discovery,
No,
you
and then
know,
it starts to get wild, right? Like so you take for example a company that has a design studio of, however many designers, and you could start to outsource the design work, but it was proxied or brokered by this agent. Like you'd go to the agent and you'd tell them the brief. You're like, I want it to look like this and that, and it would work with you, and it would sort of auto generate some images to be like that or more like that or like that, whatever. And then it would go out and find someone, and so you'd get this burstable workforce that was maintained by a constant presence within the org. So it's like fronting the human labor with this agent. And you drop that agent in, and it becomes quite a valued team member. But its most valuable asset is that it can call on people, the appropriate people that could be international at the right time for the right price. It communicates smoothly. It can communicate multilingual. It negotiates prices and contracts and all that in the background for you. And as the consumer of the agent, you get presented with an offer of a price and an agreement of the work. You pay it. You just go, yeah, mate, do it. And then the work comes back, right?
yes, and that same stream you could also talk to as far as services.
Yeah, things to do, right? It's like, hey, where's my lunch? Or where's that container load of stuff? Or what happened to the digger?
Yeah,
Like,
or where's my weather report?
yeah, exactly. And so that one agent starts to get pretty busy, man,
Yeah, I like that a lot.
right? And that's where we tap. That's where we skim labor.
Good. I like
Yeah.
that a lot. Right, I really do need to go.
Okay, buddy.
Short by quite a bit.
A lot. Thank you very much. That really helped a lot. I was able to see our landing point.
Yeah, what you're doing right now is still absolutely the right thing to do.
Okay, great. I'll keep at it.
Yeah. Right,
But
man,
you got some work to do, hey?
Yeah. I don't know how many days. I will think about on Friday.
On Friday we'll go over it. Yeah, because now we know what landing looks like. You are the one that is on the ground waiting to receive. Like you're the catcher.
Yeah.
And there's stuff you can do to be ready to catch.
Which is brilliant because I've been feeling a bit like a spare tool.
No, you never were, but man, you always come up with some interesting stuff like Tifu and now Tanzania. Like that's what. Oh, the MOU about the island.
Oh yes, good.
That would be good.
Good catch.
All right, I'll stop recording, eh?
Yeah, you stop it. And also